let me begin by introducing Senthil Kumar Doss, or aka Skud as he is also called. Skud graduated from the Regional Engineering College Trichy in 1999, and he began his architectural career with an internship at the studio of architect B.V. Doshi's office in Ahmedabad. And subsequently, during a visit to Auroville, met his mentor, architect Dominic Dubé, where he had the opportunity to associate with him and work on the master planning of sustainable housing schemes in and around Auroville. So Senthil went on to establish his own practice under the banner of Play Architecture, an experimental design studio at Bangalore. And a common interest in timbrel vaulting also paved the way for an introduction with the legendary South African architect Peter Rich, which is now incidentally transforming into more meaningful collaborations and other partnerships that he does with his studio. So if we can really begin, Senthil, you mentioned the studio is experimental and research-based. So could you take us through some of the experiments that you are involved with, and what kind of research does the studio like to get in?
Yeah, thank you for the introduction. So post my graduation, I moved to Auroville, where I met Dominic. So Auroville was the first playing ground, and experimentation is not new in Auroville. So I think you start in a place where experimentation is like bread and butter. So that kind of paved way. But I also was interested in theoretical side of architecture, where the practice, when we started Play Architecture in 2005, I was working with Dominic, who was more a modernist and who was turning into a minimalist. And by nature, I was more a deconstructivist. So what was happening there was we were beginning to test various isms. My learnings with Dominic for the first 5 years, and then slowly exploring various other isms in architecture. So we made it a very, what do you call, like a all-inclusive practice in the beginning, trying to search for what would be an ideal platform to set our ideas. So from there, from being a deconstructivist, I think if you look at a certain shift in the trend, people were moving towards parametricism and computational architecture. So we shifted there, and also found very recently the merging point of parametrical processes in combination with critical regional thinking. So I think this is something which is getting really interesting, and world over it is becoming a popular idea. Where earlier parametrical thinking and parametrical architecture was seen more a form-making stunt, which is becoming more meaningful in terms of adding parameters and layers in the design process. And you also bring in rich value of intuition. So this way, the practice is extremely intensive. We do a lot of work on-site, hands-on. Parallelly, we also do a lot of these software computational researches, and they both kind of marry and merge at this point. So I think this is one area where we are finding ourselves very, very comfortable. And my root comes from, I have a small martial arts interest and background. So the idea of a relevant technique and constant practice, I think that's something which adds a lot of value in our process.
Wow, very, very interesting to note. There of late also has been a big interest in vaults for the practice. I think that is something that you have really reached out to. So there are really so many different types of vaults out there. And specifically, how do you what has been the interest of the studio in terms of researching the specific types that you have been? Because I mean, there are a plethora of vaulting systems that exist.
Yes. So the first trigger for this happened with one of the engineers who posted this on Instagram from ETH and world over. And then I happened to trace that the root of this timbrel vaulting went back to architect Peter Rich, who has become a great friend, philosopher, and guide to me now. So my initial days interest was, I was extremely curious when you see masonry vaulting, which seems to be addressing tensile forces. So I was very, very curious. And at this point of time, we started a research at Care School of Architecture, Trichy in Tamil Nadu, where I was working with catenary based structures. So the research started there. And when I happened to see this, the question was if masonry systems could be done using various varying catenary arches. If we connect to connect them together if it forms a stable structure. So this is where the inquiry started. And having then traced back the roots to Peter Rich there. And one day, suddenly I get a call from Care School of Architecture, Trichy, saying that without any question, can you please reach Trichy tomorrow morning? So I was asking as to why, and it happened to be Peter Rich visiting India, and he was in Tamil Nadu, and he visited Care School of Architecture, Trichy. So I was able to share my research with him in the initial days of drawings and the small experiments we were working with, and and then it just fell in place. So
specifically, your area of interest is a particular kind of vaulting systems. Is that what you are looking at in terms of researching? Is it the timbral vaulting systems, or is it some certain other types that you are looking at?
See, the roots from Auroville gives you like we have been trained looking at all the Nubian walls, the semicircular walls, the arches, domes. So the root was in 2000 beginning. And then when I found timbral vaulting, what interested me was it was looking like it was addressing tensile forces. So I became curious there. And 6 years from the research, I realized that it is not addressing tensile forces. So there was a lot of curiosity in the beginning. I think that is where the timbral vaulting is very specific to me, is interesting. And we are also working with all these other kinds of regular arches and domes.
But Senthil, tell me, these vaulting systems have been around for a long time.
Yes.
They have been, over the course of the years, been put in many places, and in fact, in a sense, perfected by the years of people having built these structures. Mm-hmm. So what is the research or the next layer of investigation that you are aiming for? Is it applying certain other kind of forms to them? Is it testing the boundaries of what you can do with these vaults? I'm curious to know, how does that play out, considering that they've been around for the time that they have?
See, if you were to date back to what Antonio Gaudi was doing with his research with the catenary based structure, he was working with a hanging cloth and hanging chain experiments. So which is a three-dimensional catenary. And then my question was, if you have, like, say, a catenary arch is nothing but a hanging chain.
Yes.
It is in tension. The moment you invert, it becomes stable. It becomes the most stable form in compression. So the question is, if you have these series of these changing catenary curves, if you just connect them together, that's my question. That's the question which intrigued me. So if you connect them together, does it still form a stable structure?
But wasn't Gaudi doing that with intersecting catenary vaults and other such series, or that was not being attempted at the time?
I think Gaudi's contribution was, if to my understanding, is more with the hanging cloth, which is a three-dimensional catenary, which is a different method of working. Okay. Here, a very, very simple system where you have series of these catenary arches, varying lengths, varying spans.
Okay.
And you're kind of trying to connect them together to see if it is stable. So that's the first question which came to our mind. That's where the research is different from what has been happening. And to go a little more deeper, it is also talking about now resistance through form. So where it becomes extremely form active, your form transfers the load to the ground seamlessly. I think this is something where by means of bending, if you were to look at my earlier other projects where this idea of bending came. Yes. Like if you're talking about a simple example, could be a folded plate structure. A folded plate structure brings down you reduce the thickness.
Yes.
And you can span bigger.
Yes.
So all these ideas started kind of overlapping in this. So we are not talking about purely compression-based structure in what we have been doing. If you take up DevaDhare, this project which we took up as our case study for this discussion, so you are talking about certain axis in which the load is being transferred. So it is more axial compression. So on another direction, it might visually look like a tensile form, whereas it is not tensile. It is still compression, but more in a certain axis.
So could you take us, so essentially you're creating multiple access points that transfers the compression load into the ground. That is how it's happening. And by manipulating the form with certain technologies, is that what you use, parametric software, or is there certain other proprietary technology or certain other applications that help you devise these systems?
See, the whole conversation in the beginning was that when we started looking at all these researchers, it looked like you need to be super precise in terms of your execution and need a software which will analyze every load at every point of the building. And slowly, by being hands-on, we realized that if the logic is right, the structure can still work. You need to be having a certain amount of experience in building timbral vaulting and also understand how the forces work. It took some time for being an architect to understand the forces, how these geometries help in transferring the forces. But the moment we understood a certain logic, so the entire experiment has been about how you can utilize this, how you can use these catenary curves to kind of establish various forms. So as a practice, I think we were also doing a lot of work with geometry in the beginning, geometry and materials. So this is a continuation of that process.
So essentially now, do you use any form finding software to actually devise these structures, or it is now you're away from that? Even not even to test after you actually devise what kind of system you want, would you apply it to test, or even that's something that you stay away from?
We have not tested the vault, what we have done, which is spanning 16.5 meters span. The initial days, we went through a process of using Gangaroo, the physics engine, for form optimization. And then a friend would come back with his master's from IAC. So he was helping me with the computation. So we were trying to do then taking it to Karamba. But at a point, you realize you don't need to be doing such a rigorous process. So if you understand the logic, if you understand the way the forces work, the way the technique of the timbral vaulting, then it becomes really simple for you to do to execute a work like that. So we are not into any software now. We just use Rhino because it gives you a catenary curve the moment I pick 3 points.
Sure.
You get a catenary curve, and then we are using it in a certain axis. And we also realize that at times, the beauty of timbral vaulting is with our very imperfect experiments in the beginning. What had happened was we just were curious and then had a geometry which was not symmetrical.
Mm-hmm.
Which was not symmetrical. And we just connected and created a timbral arch. And then you feel if it was any other vaulting system, it would have just come down the moment you remove your formwork if the geometry was not right. Yes. But timbral seems to be holding up, which made us overconfident. Is when one of the first experiments in timbral vaulting at Cap School of Architecture failed, because having seen this, we thought we should push. And I probably misunderstood the concept that it was working well in tension, which was not the case. So in the later conversations we had with one engineer by name Philip Block, who's also having the patent for the Rhino vault. Yes. So in one of the conversations, I just asked him this question, and he said, Senthil, yes, but it's local tension. It's not global tension. It is not the tension which happens in the overall form. Timbral vaulting is capable of addressing small tensile forces which happens within the layers of the vault thickness between different layers of the mortar and the tile.
Essentially, it remains to be a compression system almost completely, and the small tensile forces that exist are in the mortar or within that you apply.
Yes, it is between the mortar and the pattern. You crisscross the pattern in every layer, you make it different. Yes. So that it starts behaving like a mesh.
Amazing. Oh, really, really interesting to know. So maybe we can start with going through some of the learnings that were there on the DevaDhare project of yours. If you could take us through really what the challenges were, the brief of the client, maybe that could be and of course the intent behind the need for such a kind of a structure to exist.
A very good friend of mine who is a civil contractor, he had this 10-acre property, and it had gone into a legal issue for almost like 8 to 10 years. So, and he had casually added some cottages, not knowing what the future of this property is going to be. And 3 years before, he got them cleared, and he won the case. And is when he approached me and said, "Now it's time to have some vision in the project." And there was a beautiful bund wall and a lake, and he happened to have got some GI recycle pipes elsewhere before the lockdown. So he had just dumped them and very intuitively added these GI pipes right in front of the lake, hoping that he would one day have a floating deck or whatever, a platform there where he could use it for some purpose. So it was just very thoughtlessly, very intuitively done. And when he invited me, he said, if you don't want them, I can always remove them. And you can envision the project from scratch as a new like a new project. So, but my interest was the moment I walked in there, I found this steel GI pipes going very beautifully with the columns, with the forest of trees at the site. And the level in which he had stopped the project was just, if you create a platform, it's just going to look into the lake. You are going to be in touch with all these natural elements, and it did not disturb at all. The only like technically not so correct side was it was hardly a foot and a half deep foundation, which was done for each GI pipe, and they were all isolated. So the question is, we are technically looking at the slenderness. If you are going to look at what kind of a load one can add. So if I need to add another floor, if I need to extend few columns, what would happen? So what I said was, let's separate the two systems. It became very, very simple. Like we can create a floor just by connecting these existing GI pipes and then separate the roof from the floor. Thereby you create very minimal intervention at site. So it's an extremely ecologically sensitive site.
Yes.
And if we need to remove the GI pipes, GI columns, redo them, make it deeper, we are going to have a major impact in the natural settings. So we stayed away from that and just created those 4 pedestals where one could actually spring the timbral vaulting from. So those were the only points which were added. And what was also beautiful is we initially thought about doing this in thatch. So if thatch roof, like a light system.
Yeah.
But the client felt that it was too temporary. If we do concrete, it's going to be too permanent. So we needed something in between. And this is when I think we had done installation for an event for IIID Bangalore called Designeru, where we had done a small mock-up of timbral vaulting at MG Road. And I happened to take the client and show him that this is what it is. And the intention of this system is to do long spans. So if in case you are interested in trying it, I can do this as a proposal. So he said, if you're confident, we can go ahead. That's how it started. Yes. So we just separated those two systems, the floor and the roof system. And it worked perfectly. So what it was also doing is it was removing the layer of intermediate columns at the usable level.
Yes.
So we could plan our floor plate. It was so flexible that one could have a dining space one day, and it also transformed into a wedding hall when the client's daughter got married there. So we just removed the furniture and used the entire space looking into the lake as a wedding dining, like a wedding space.
So essentially, this entire form of this the architectural expression was all organically sort of evolved. Would you say that, considering there were already the columns there, and then you had this system, and so there was not a preset idea in terms of even spanning it across this sort of creek that exists. That was not the intent.
Not at all. It is basically what the site tells you or teaches you. You need to have a conversation with the site. You need to be speaking with the site in a context like that. So we need to forget that we are architects and leave the baggages of whatever we have been trained with or whatever we have been taught with. Yes. And just be responding to what you see there and what you need to be doing there. It's a very spiritual process, I would say.
So often these structures, these catenary structures, are confused with suspension structures. So how does one actually negotiate that? I mean, how does one kind of, because they look very similar, almost in the way that they are, in their shape and in their form. So how would you differentiate between these two ideas?
Looking at it, the moment you load a catenary structure, it becomes a parabola. I don't know too much of mathematics and geometry. So the basic difference between a catenary curve is not a parabolic curve, if you look at the mathematical expressions.
Okay. But could you elaborate a little bit more on what really defines a catenary curve? Are these pure foundation curves that exist?
Yeah. If you take a catenary curve, for example, the line of thrust, the idea of line of thrust stays within the shape of the catenary. Basically, the horizontal and the vertical thrust is transferred from one point to another, lying within the catenary curve itself. And
all right.
take a semicircular arch, for example. I'm taking a semicircular vault or an arch, for example. You design it in such a way that the line of thrust lies within the 1/3 of its thickness. Say if it is 300 mm, you divide it into 100, 100, and 100 mm. So in the middle 100 is where your force line needs to be. Otherwise, there would be a collapse depending on where the shift is. Either the arch or the vault can collapse from the inside or from the outside. So in a catenary curve, the geometry, because it is nothing but the inversion of a hanging chain. A hanging chain is in pure tension. And the moment you invert it, it becomes a form in compression. So it is, to me, the thickness or the density of the material doesn't matter when you're using a catenary curve, when you're using a catenary arch. So if you're doing a semicircular arch, to control the thrust, you need to be adding volume. You need to be adding thickness.
Yes.
Either you compress them or you increase the overall thickness of the form. In this case, you can just work with the minimum thickness. I think that's the beauty of working with a catenary curve.
Because you're working with compression and not tension.
No, compression. Even the other arches are in compression.
Yes.
But just to handle your line of thrust, just to control your line of thrust,
yes,
you would be adding a lot of mass at different points.
Yes.
From where it is springing, where the thrust is happening. So if you look at traditional arches and walls, you will see a thicker base.
Yes.
Then it becomes thinner as it goes up. In the middle, it is thinner.
Yes.
Just to control the line of thrust.
So in a case like this, because the thrust lines stay within the curve itself, you are able to control the thickness of the curve to the thickness of the actual system to a much larger extent.
Absolutely. We are now doing walls which are 35, 40 mm thick.
And what would you use for something like that? Is that a challenge using clay tiles? Works okay?
Depending on the span, we are using 10 to 15 mm thick clay tile, like just 2 layers. 2 layers is the minimum for it to be classified as a timbrel vaulting, because the first layer is always considered to be a formwork. The moment you add the second layer on top, the formwork also becomes part of the structure. So we are just doing 2 layers. We are doing spans up to 10 feet, 35 mm thick, looking like a piece of paper, and sending 4 or 5 people up, walking, jumping, and playing around with it. Yes.
So also in this particular system, like you mentioned, the span is completely devoid of any kind of columns and things like that. But are there any challenges related to water ingress and other such things which have to be negotiated because of these systems? Will that cause a weakening over time if it is allowed to permeate into the layers?
Absolutely, yes. So our initial experiments happened 6 years before, and where we have not done any waterproofing, and we have just in fact used, traditionally Tamil Nadu has these bricks which are like 30 mm thick, 25 mm, 30 mm thick. We used to call them achakal, which is not too dense, like in terms of like the making. So it is very porous. So what we have realized is after 6 years, it is not maintained, and you can see the layers are getting detached from one another. So these are the earlier experiments. So what is advisable is to have a layer of waterproofing. Sometimes we are the project at DevaDhare has a clear coat like a Zycosil, and we made sure that we are the joins are filled with epoxy to ensure that there is no water entering into the structure and making it. There are, because this place where the site is, it's called Sakleshpur, which is one of the heaviest rainfall areas in India. Apparently, somebody said it's equivalent to Sirapunji. And we have few dampness areas which we are addressing because we still haven't done the epoxy grouting fully. So we're just allowing it to see what has been happening as well. So it is advisable. And even when you do the mortar layers, have waterproofing compound in each layer. And the final layer, you do a Zycosil with a epoxy grouting.
So are you able to also insert some kind of membrane or something in the topmost layer? Is that something ever been considered, or that causes more?
We can do that, but my learning from architects like Peter Rich, who are talking about the authenticity of a vaulting system,
Yes.
So it's a tribal traditional art form. We still stick to that. Whatever we are doing, we have not done the membrane layers or any of these metal meshes or these fabric meshes.
But
So
technically, it could be done, and then chances are it would extend the life of the structure significantly, considering that would the problem related. Because I would imagine water would be a primary concern. Otherwise, there would not be further deterioration on the sort of science of the way the structure stands.
Mm-hmm.
Is there some kind of forecast in terms of how long these structures are expected to actually exist before they need certain kind of, because I don't think you can repair something like this. Once it is constructed, I mean, it remains the way it is. There's no system of repairing or restoring.
You could restore. That's
yes,
yeah, you could restore. Yes, there is a possibility, because these are sandwich layers, and you can always work on them. We have done, like, it's a kind of notorious activities what we did in the early part of our research, where you kind of push the limitations, and you push the structure to a stage where you try and test a lot of things. So we realized that if needed, if there is a real need for restoration, one could do that. But as you said, it's great to improve the life cycle. As far as the theoretical reading we have done, in Spain, these structures have existed 400 years before, which are still active. In the US, Gustavino thin tile vaulting has been surviving for 200 years. So I don't see.
But with ETH, I think in recent times, these systems have started sort of making a comeback even on the global scene. You see many such buildings now with these form finding software and other proprietary software that is available, who have not, of course, gone through that extensive research and R&D process that you have gone into to actually build this. Because I would also imagine labor is a significant component of creating this accurately. I mean, your own personal time and effort would be needed far more at the site than some kind of contracting service that would be allowed to build something like that. So how has that experience been for you? Is that a challenge? Are you able to kind of, as the experience builds, are you able to kind of assign or direct others to fulfill these kind of systems quite efficiently?
The first 3 or 4 walls when we built, I couldn't sleep when the work was going on. So I was always at site. So it was always giving you butterflies. And there was a situation, I was invited for a what do you call, like a charity project in Mirzapur. And all that we could do was another friend, colleague, architect from Ahmedabad requested me if I could join him and help him in doing this work. All that we had was a 10-day slot, and we had to execute this vault in 10 days. And then I go to Mirzapur, I go to the site, I realize that there is no electricity on site. There is no labor who even understands basic. And there was a 75-year-old carpenter who was manually cutting the vertical supports, whatever we need for and they should have kept the foundation ready, which was not. The digging was midway through. And we had funds only for flying us to the project once. So what it taught us was, the day I left the site, we managed to do the steel, the technique what we have developed using steel reinforcement. So we just managed to erect it, support it, and taught the labor how to do 1 meter of first layer of tile and second layer, and said, all that you need to do is another, like, keep continuing the same process.
Yes.
Keep adding it. And we were keeping the fingers crossed, literally. And they took a month, which they should have actually taken like 10 to 12 days at the max for doing this. But we were surprised to see the baby standing beautifully. So, so when I realized that you have also understood the technique well now, and we were guiding them through videos if they had any issues. If in case there was any need for any clarification of correction, it was happening online. So then you realize that you have understood the making, and you were able to kind of communicate. And you don't have to be personally now be standing there to get this done every time. So that's the deeper understanding you get. This is where the Bruce Lee story comes. He says, I fear the man who has practiced one kick 10,000 times than a man who has practiced 10,000 kick one time. Sure. So I think rigorous practices taught us how to address, And every time we go, there is a new situation. It is never, you're working with a new set of people.
Yes.
And then you kind of take it up as a challenge. It makes you grow spiritually also. So you're just living for that moment and then trying to build something in that given time and money.
So now, how many such vaults has the studio actually engaged on?
I think easily 10. We have done,
10.
we have done 2 at Auroville. One recently in Hyderabad for a developer who was very curious about how the temporal vaulting works. So we just happened to teach their team on how it works. And probably 9 to 10 now.
And there is an ongoing sort of interest in this. Are you still receiving many such proposals or requests for proposals in terms of devising such systems? And that's an ongoing, because it is really a very sustainable method of building in the sense you're using largely local material, local labor, no steel. I would imagine that, I don't know whether any cement really goes in the mortar mix that you create, marginal possibly. But in a sense, it's a very lightweight structure that you're able to create, which of course, in terms of its physical expression is really exceptional in terms of the natural kind of forms that it imitates. So it really is an amazing aspect.
Yes.
Incidentally, so I'm just curious to know, in terms of your thoughts related to sustainability and this entire sort of direction that it's headed, do you have any views in terms of how is it, or in terms of what's happening in India? What would your views be in terms of this entire sort of I would say interest in sustainability? How much of it is, do you have a thought on that?
Yes.
How it is specifically working in India and whether it's headed in the right direction?
Yeah. In fact, I think this is where this initial introduction, when you spoke about architect Peter Rich, I think he has been a constant mentor to me in this area. Every week basis, we discuss things. And if you look at his project at Mapangubwe, he had done hand-pressed tiles, which is even more sustainable. There is absolutely no embodied energy involved in that. So with one of the contractor firms in Auroville, we are trying to develop a mud tile or a mud block, which is very thin, which can be less than 30 mm. And Peter also suggested that I should collaborate with people who are working with lime. So we could kind of slowly eliminate cement in the process. At the moment, we are using cement. So the next steps could be preparing mud blocks, hand-pressed tiles, and probably use lime as a mortar. So these are the areas we are venturing into. And as an individual who is extremely experimental or notorious and curious in nature, we tried making a kind of cantilevered masonry. We made an attempt like 3 months back in one of the workshops in Bangalore, where it is symmetrical. You can probably refer to our Facebook or the Instagram once they are all safe to use now. So we are just trying to understand the force lines more better. The moment you make a symmetrical cantilever structure, partially it was successful, and we had just made like some 35 mm thick, just wanting to test and see where the failure could happen, how it performs. I think those geometrical questions are very, very personal to me, and talking to somebody like Peter, whose super focus is towards achieving great level of sustainability. You cannot do anything 100% sustainable. I think nothing we do in this world can be sustainable that way.
But in general, your views on sustainability in India and the practice and the direction it's headed with architects in India, do you believe enough is happening on that front? There is a little bit of greenwashing that is happening. What is your call? Or there should be far many more projects that kind of entail such kind of efforts?
A lot of greenwashing is happening. I think we need to be consciously pushing different techniques. I think that's somewhere, I think we just fall into a comfort zone of if there is a dome or a vault which is built out of mud blocks. Even if you look at Auroville, one of our ecologist landscaper from Auroville did mention that Auroville is not as bold as you are now. So you find a material like rammed earth, and then we settle there for the last 30, 40 years. So we need to be constantly questioning and pushing. So if everybody is using earth, is it still going to be sustainable? And at what context? If you're going to get earth from many kilometers away and still do a rammed earth, I think sometimes these, what do you call the greenwash does happen.
Yes.
But in the last 5-10 years, you are seeing a very, very a creative push which is happening towards. You cannot say that it is not happening. I think we are stepping up to a great extent. Not just us, but many other practices in India are like looking at this very critically and trying to take things forward.
What I always find interesting is that there always are these few leaders and sort of super experimental studios and architects that go about in researching these ideas and technologies, and the entire team that works with them. Often you find that now they take it upon themselves to further this research and further this investigation, leading to a really exponential number of such similar experiments or projects happening across the country. So that's always a enriching area, that they actually fall so much in love with this idea and this methodology and sort of this process of discovery and learning and rigor, that they imbibe this and take it forward in terms of their own efforts that they do independent of the place they interned with or the studio that they actually worked at. So really it's been an exceptional experience learning about DevaDhare, which brings me to this also lovely project of yours that I saw. It does not have any earth. There's no the force lines and thrust lines, and the science is completely in another direction. So maybe I can play that video that you shared, and then we can maybe talk about it. So the guys tuning in maybe have somewhat of an introduction in terms of why this is really so special. So let me just.
Yes.
Quite something in terms of what you're attempting there. So could you take us through that that project and how it's really shaping up?
Sure. So this entire inspiration happened when I wanted to build my house. So I had a property in southern side of Bangalore, southern part of Bangalore, very close to the Bannerghatta forest. In fact, the site where we are sitting on is a quarry land. But unfortunately, we cannot take any stone out from there because the quarrying has been banned there. And one of my like a trip to one of the temples in down south, like you go to Trichy, Tanjavur, you go to Kumbakonam. So this a very insignificant temple, insignificant from the fact that it was not popular, but we were advised to probably go there. So I had been with my wife and we were sitting there at 5 in the evening, and then you just see this the evening sunlight just wash the surfaces of the stone. So it was very poetic. That moment was very poetic, and then it made the entire space feel like so light and like air. And we are talking about a material which is so dense and heavy. So I'm sure we would have been looking at this for since I was 10 years old when I could actually start looking at buildings. But it was a point of a point of what do you call like it just turns you inside out, and then you feel you need to be working with a material which is as beautiful as stone. I come back knowing that Karnataka is famous for chabdi, and then unfortunately you will see chabdis being used as drain covers. To a larger extent, you will see a lot of compound walls if you go to the periphery. Yeah, if you go, you'll see people using them as compound walls. And I'm sure Catenary brothers, who were one of those early people who were working a lot with chabdi as wall systems, they used to make these concrete columns with sleeves and then interlock them or whatever. So the question again, like the way the Catenary connecting series of Catenary, here the simple idea which came was, if we put 2 or 3 chabdis together, will that form a stable system? And if we could interlock, so I was like a child doing these Lego blocks with chabdi, and then we interlocked, and then I went to meet the structural engineer BL Manjunath. We are friends for the last 16, 17 years. I think more than professional relationship, we have become like friends today.
And he's another one for experimenting a lot. He really thrives on it.
So we had a conversation, and Manju said, but Senthil, the way you look at, do you have a lot of money? I said, sorry. He said, in spite of whatever you aspire to, there is still a lot of architect in you. I might have to rearrange the order. So he told me that you cannot just be an architect in this project. I will not just be a structural engineer in the project. And the team with whom they are working with, they cannot just be contractors or vendors. I think we'll have to be in unison in this project, shifting shoes and probably working together. So then I said, I will give you complete freedom in terms of rearranging. I think the order really matters here, the way you interlock them.
Yes.
So that it gives you stability. So he said, I have taken your intent. I will interpret it in the right way so that it forms a stable structure. And then the moment I saw his initial, like the arrangement, I just decided that I'm not even building walls anymore after that. So we just opened out, took the walls to the periphery, placed the wall. It also becomes a very modern interpretation of the mandaps, what you would see in southern parts of India. Yes. It's a typical 9-grid house.
Yes.
With the center open. So we were debating about if we should keep the central core open or if we shift the cores to some other part to kind of make it more contemporary, but went back to the central core idea. But the moment you lifted the walls, moved it away from the structural system, the way you speak with space was something else.
So it has a perimeter. Are these Gabion walls that kind of that are controlling some of the sort of lines of sight into the structure? Is that how you've arranged it?
It was, frankly speaking, Gabion walls is more the economy reason, because I had a lot of waste after we cut the stone. We had a lot of remaining stone left over. So talking about the Gabion wall, I'm talking about not the primary structure, but the structure which is outside.
That controls really the site and gives you that first level of security, and then you have the structure that exists within, and you've not And that remains as a purely structural system with no other kind of buffer walls or kind of infill that you've kind of used.
Yeah, we do have glass infill, so you need to be controlling the weather.
Sure.
And
Sure.
what is happening, the high walls, in fact, creates this layer which can bring down the harshness of the sun.
Sure.
A stone, which is only 100, 125 mm thick, can be hot. But I think to me, this project is more about the soul than the technique even. No?
Yes.
This is being brought about by the material, by the way you arrange the material.
So in this, again, you've used local labor, etc. And I would imagine the joints is really a critical part of this system for it to all hold good and stand the test of time. The question is, how important are the joints in a system like this? And does the structural interlocking system sort of mitigate the risk if the joints are not done as well as they should be done? That's essentially the question that I have.
Yes. The first challenge in this project was I wanted to use chabdi, which is a natural formation. If you're talking about Sadarali or a Sera, stone like Sadarali Sera, which are blocks which can be cut into a exact dimension, it would have been much, much more simpler and easier. But the beauty of chabdi is through nature, you get this unfinished surface on either side. And the challenge what you would face there is it's probably 6 inch at the bottom, 3.5 inches in the middle, and probably 5 inch at the top. Yeah. So whenever you need to interlock two things, there is always this challenge of how do you like kind of touch them to each other, because if they don't touch, it is not going to be stable.
Yes.
So we had to figure out lots of ways. We had to work with the labor to grind certain parts, assemble them together where they are touching. And when the column and the beam interlocks, you cannot make a straight template and say, I'm done with it. So we were there identifying each and every stone. One of my colleagues called Periyasamy, who has been spending his last 2 years there. So you lift that entire slab, mark the thickness of the column onto the beam, transfer it there. And then on the other side, it's going to be another thickness.
Sure.
So there's a lot of drama in terms of, and then if it goes beyond 3-4 mm, then it does not give you the strength. So at a later stage, we also went to the extent that a couple of stones started breaking because it was too tight, the way you want to lock them and you interlock them.
Yes.
So then we tested by leaving a bigger gap and then inserting another thin layer of stone, sandwiching it, pushing it through. So we have done a few things which has also given us some better understanding of how it could work. Ideal when it just locks perfectly and sits there. Even otherwise, there is some threshold which you can play with.
Yes. It really is really pushes the boundaries of experimentation, and it with a completely different material. So it's a completely different kind of learning that really one has applied on it. So really, it has been an absolute delight, Senthil. We're running a little out of time. There's a last slide that I have, and this has been. I saw it in one of your presentations, and you commented about how these Pringle chips are in fact also derived from these vaulting systems. So yes. If you could just share on an ending note in terms of how this actually behaves and really the inspiration behind this sort of evening snack that one has.
I think the structure next to it is Felix Candela.
Yes.
And the Pringle, see, if you are looking at the minimal surface, the idea of minimal surface, like the least resistance created by a surface. So we are talking about structures like parabolic hyperboloids. The Pringle also falls into one of those families.
Yes.
Where timbral vaulting can be extremely functioning well. We might just have to look at the end conditions, because minimal surfaces, if you're talking about, needs a stiff edge around it. So we might have to probably use a steel member or whatever around it. Yes. Probably can do a vault, on that. And I think Pringle, kind of figured this out, because initial days of their chips were cracking inside while transporting, and then they wanted to make it thinner and thinner and thinner. So it's a perfect shell that way. And then the moment you stack Pringle over with the shape, they were able to reduce or even remove the breakage of chips. And anytime when people picks it up, you get a full form, you feel happy. I think that's what that company was talking about. So there was a lot of times which went into that, which was a very interesting story to read.
Yes.
I think we were talking about this in one of the schools in Jaipur. So
yes, I saw it. I saw it in one of your presentations, and it piqued my curiosity in terms of this particular form that exists and how it's kind of being replicated in so many different areas and ways. So really, it has been a delight. I don't think we have time. We are on. There are some questions possibly, but I think a lot of them have also been answered by you during the course of the discussion. So it was absolutely a delight in terms of what you're doing, and I wish you all the success in really pushing these boundaries and experimenting more with the various initiatives that you have taken upon yourself to really push. And I admire your sort of learnings from martial arts and the idea of repetition and how that leads to perfection somewhat. So excellent talking to you, Senthil. Thank you for taking out the time, and wish you all the success.
My pleasure. Thank you and your team for making this happen. Also, thanks to architect Peter Rich, who found time to join us in this conversation.
Oh, lovely. So, glad that he's online as well.
Yeah, so I'm like extremely thankful to him for all the learning and the sharing which he has been doing. And I hope I will grow with people around him and so many other people to take us far. Thank you so much. Yeah.
Thank you so much. Have a nice evening.